Today we will be taking up mostly problems from determinants and matrices, because that is one of the most important topics that carry more weightage also. And in the recent times, the weightage of matrices especially have increased. So our main focus will be on determinant and matrices too. So we'll start with the first problem. Yes, beta. So this is a second order system, and that too a homogeneous system. So there are only two possible cases since ABC are real. What are the possible cases? Either a unique solution, which is also known as trivial solution, or a non-trivial solution, or combination of both depending on ABC. So tell me, what is the option that you are getting? Tell me, what is that? Yes? Sai Rishi, Nikhil Gandhi, Ved Prakash. Anybody? Yes? Are you doing it or not? All of you?
Yes, sir. Trying this.
Doing this. Tell me, what is D, first of all? Trying this, no? What is D? Tell me first. So this should not take too long. Tell me. So D for this system is going to be ABC minus. So now you tell me, looking at this expression, what is instantly coming into your mind? You must tell me, looking into the expression. Yes, these type of terms are there in what? Is triangle coming into your mind or not? Like ABC is there, B plus C minus A. Say yes or no.
And that is equal to 0, no, sir?
No, that is not given. You have to tell me, let ABC be distinct. Why this is 0?
Because if we substitute x and y in those equations, we are getting the same values for those.
No, that's always the case, man. That is always the case. That will depend upon, yes, that you can try. But that was not based on solving this. Okay, you have done it in the other way. So that is also fine. So I can't tell you that that is an incorrect method. So non-trivial, yes. So, but D obviously will all depend on D you are getting as 0. I don't think D will come out as 0.
Yeah,
Solutions
sir, if D gets 0, I will get only one solution.
No, D, see, I don't think D is 0. See, ABC are distinct numbers. Let us justify. Let us first justify why D can, I don't think D can be 0. See, suppose let me take without loss of generality distinct numbers in this manner. Right? So tell me B plus C, C plus A minus B. What is the sign of C plus A minus B? C minus A minus B is always positive, right? And A plus B minus C is always positive. Yes? And then
Yes,
what will decide the overall sign? What term will decide? B plus C minus A. So let me split this into two cases. Case 1. So let me take B plus C smaller than A. B plus C smaller than A. Then what will happen? Then what will happen? Less than or even equal to. Doesn't matter. They are positive. B plus C less than or equal to A. So this sign will become, tell me? Negative. So overall, what will D become? Strictly positive or not? In the first scenario.
Yes.
Correct. Similarly, case number 2. So case number 2 is B plus C greater than A. So A greater than B greater than C, B plus C greater than A, C plus A is already greater than B, A plus B is greater than C. That means it satisfies all the conditions for ABC to represent sides of a triangle. Do you agree or not?
Yes, sir.
भाई इस केस में क्या बन जाएगा? I can take representing them to be the sides of a triangle. So now I want to bring in some factors here. So ABC is what? 4R delta. Capital R is ABC by 4 delta. Remember the formula? Tell me.
Yes, sir.
And this is 2S minus 2A, 2S minus 2B. So 8 times it will come. No? 8 times. Now this has become a problem which JEE has already asked some 10-15 years back as a subjective problem where you need to show that this is always positive. And inequality holds when the triangle is equilateral. So let us just observe this. So what am I going to do now? So I will multiply S divide S 4R delta minus. What is this? Delta square. Is it clear? And what is delta by S?
Yes, sir.
This is small r. Small r. So I can take 2 delta common, 4 delta common. So r minus 2r. And everybody knows that r is greater than equal to 2r. Are you aware of it or not? So this will be strictly, tell me, greater than or equal, but equality can only hold when triangle is equilateral. ABC are already distinct. So D in any case will be positive. Hence this will always possess infinite solutions, non-trivial solutions. Is that clear?
Yes, sir.
Understood? No? So you might have done some mistake. Please check your working again. Okay.
If
So
delta is greater than 0, it will be trivial.
pardon me?
If that is greater than 0, it will be trivial.
Just a bit, not infinite. D is not equal to 0, trivial solution. So for trivial, basically it is unique solution, D not equal to 0. And for D equal to 0, what do you say? This possesses infinitely many solutions. Correct. And what is the trivial solution also? This is only 0, 0. So when I say trivial, that means only 0, 0 is there. And when I say D equal to 0, so along with this, see 0, 0 anyway will always be there. Along with this, there are infinitely many. So I think this is understood to all.
How to prove R is greater than 2R?
That you don't know?
Yes.
No issues. Small r, see for that some basic formulas you must remember. 4r sin A by 2, sin B by 2, sin C by 2. This you know or not?
Yes, sir.
100% no. So even if you want to derive this, this also can be derived by taking r as delta by s. So that you can write delta as half BC sin A and small s as A plus B plus C by 2. Then you can write 2r sin A, 2r sin B, 2r sin C. You will get this result. Okay. Now here what you can observe. What is sin A by 2 formula? Tell me, what is sin A by 2? It is S minus B, S minus C upon BC.
Delta.
Not delta, 4 under root. This is sin A by 2. This you know, everyone?
Yes, sir.
So I think S minus B, S minus C, just by looking at it, I can apply AMGM inequality. I want to apply. So S minus B, S minus C under root is how much? Less than or equal to their sum. So what is S minus B plus S minus C? That will be A by 2. Correct? Similarly, S minus C, S minus a cyclic order you can take. Is that clear? B by 2 and S minus A, S minus B. This will be C by 2 under root. Now you can multiply. So what will you get? What will you get? Or do one thing. Yeah, you can multiply this. In fact, I want to bring in BC over here. So let me multiply by BC and divide also root BC. Is that okay? Within the square root only. Within the square root. And upon AB also. This is whole within the square root. Okay? Whole within the square root. 2 and AB. Now you multiply. So this is sin A by 2 formula. Sin B by 2, sin C by 2. So on the LHS, what you are going to get? Tell me, sin A by 2, sin B by 2, sin C by 2, which is small r by 4r. All right. And this is smaller than, on the RHS, what will you get? 1 by 8. So from here you get r is greater than equal to 2r. And for equality to be true, each of these equalities should be true. That means B equal to C, C equal to A, and so on. Is that clear?
Yes, sir.
So this you should remember, no? Capital R is greater than equal to 2r. This you should remember. Okay. Now let us take next problem. So this is for determinant. Determinant A not equal to determinant B. Then the value of summation R from 1 to 20, determinant of adjoint of A power R into B power 2R minus. Please try this.
So 0.
Yes, 0. What is the expression that you have obtained? Summation.
I mean, I removed B directly because that B will be 1 and that A will be -1. So now adjoint that A whole power 3R summation. That will
Whole
be
power?
A power, I mean, that A whole power 3R.
Yes.
Summation of that will be -1 plus 1 -1 plus 1.
Correct. So -1 power R you are getting. No?
Yes, sir.
Yes. So all of you should be able to do this. So this problems look scary, but this is very simple problem. See, B equal to B power 4. B is invertible. So I can multiply by B inverse. B is invertible, na? So I equal to B. If you apply determinant on both sides, so this is 1. Now look carefully, there could be 3 possibilities in any other problem. This could be either 1, omega and omega. That is why he has specifically mentioned in the problem that non-singular and real square matrices, that means omega, omega square are ruled out. And similarly, orthogonal matrix, you know, AAT equal to I. So if you take the determinant, then it could be either 1 or -1 since they are unequal. So determinant A equal to -1. Right? Now for this is determinant of, what is adjoint of? Adjoint of P. This is determinant of, what is that? Tell me, A power R, B power 2R minus 1, 2R minus 1, whole power N minus 1. N is the order. Correct? And determinants is distributive over multiplication. So determinant A cube whole power R. Summation is also there. Summation and power cube whole power 2R minus. Now you can substitute the values. So determinant A is -1. So -1 power R. This is already 1. So even number of terms, alternate plus minus, will add up to 0. Understood by all? Yes? This is P power 500. So how should we proceed? Are you doing it? P power 500. So is there anything you can judge about power of P?
Sir, is it 5?
You are getting 5?
Yes, sir.
Okay. Let me just check. What is P power 500? In fact, what is Q that you are getting? So I'm interested in Q. Na? Q you have obtained?
Yes, sir.
Okay. So you please tell me, how did you proceed?
I found P square and P cube and found a pattern, sir.
Okay. So are you sure that pattern is going to continue? I will tell you a better way to approach such type of problems. Okay. The way you have done is not incorrect. But see, instead of finding directly P square, what you guys must do, whenever you see this is close to, you should identify this is close to a known matrix. So what is that known matrix it is close to? It is close to I, है ना? By 1, 0, 0, this diagonal is same. Okay, only these three elements differ, na? 4, 8, 4.
Yes, sir.
This you must have done, yes. So let me name P as some B plus I. Can I do that? Can I do that?
Yes.
What is B? What is B here? Tell me now. This we are taking P. Okay. So B is going to be 0, 0, 0. What next? Second row.
400.
0. And then
840.
8, yes. 8, 4, and then 0. Correct. So this is your B. Now, since B and identity is a universal commuter, identity matrix, when they commute, you can expand P power 500 binomially. Whenever matrices, square matrices compute, you can apply algebraic operations as in number algebra. So B plus I. So this will be how much? Tell me. I can apply binomial theorem. So this will be, I shall start with I. So I plus 500 C1 into B like that. Okay. Plus 500 C2. This I can apply only when the matrices commute. And so on. I can write like this. So for that, I also require B square. So tell me what is going to be B square.
0.
B square is 0. No, I don't think
No.
so. This will be 0, 0, 0, 4, 0, 0, 8, 4, 0. So what will be this? Here 0 will come for sure. Here also 0. And here also 0. Is it clear now? This is also 0. And then this is 0. This is 0. And this value will be how much? 16. Yeah. And then I think all are 0.
Yes, sir.
0.
Hmm?
0, sir.
All are 0. So obviously B cube will be 0. No worries. B cube is 0. So B cube onwards, they are 0. So now you can calculate P power 500 in a better way. So P power 500, this will be equal to I plus 500. So multiply by 500 and then 500 C2 into B. So what is that going to be equal to? Tell me. And this you are separating. In fact, Q will be P power 500 minus I. So I shall write directly Q here. No? So Q will be, look above, P power 500 minus Q, this is I. So Q is this minus I. That means 500B plus 500 C2 into B square. So now you can calculate, correct? And you are only concerned with these elements. So you only capture these elements. So can you tell me what is Q31? So look at the element Q31 only. So this element. So this into 500. Is that all right?
Plus 16 into 500 C2.
Yes. So this is 4000 plus 16 into what is 500 C2? Like this you write. Okay. This is Q31. Then what is Q32? So Q32 is going to be 4 into 500, that is 2000. Plus 32. So that is 0 only. Correct? And whole divided by this whole divided by, in fact, Q21. What is Q21?
2000.
That is also 2000. So now you can solve this. Okay. And get the answer. Is that clear? How to approach these type of problems?
Yes, sir.
Yes.
Okay. Move on to the next question. One or more may be correct. Yes, tell me.
AC, sir.
A and C you are getting.
Yes, sir.
Okay. Determinant of NM is 3, is 9. Huh? That means A and C, please check. How could this be both 9 and 27? You're getting two
AD,
possibilities.
sir. AD, sir.
A and D. Huh? I think A and D should be there. Let us check. So how will you approach this? Tell me.
I found the det of the first equation, sir.
Mn square equal to 3mn. So what is the determinant value that you are getting for mn?
Mn det m square equal to 9 det m, sir.
Here, m and n are not square matrices. You cannot separate.
No, sir. Mn equal to 2 cross 2 matrix is coming.
Mn is 3 by 3 matrix. Nm is 2 by 2. Getting the point?
Yes, sir.
Yeah. So see, you should do it carefully. Sometimes our way is incorrect, but answer might come correct. So we should be very careful. See here, what is happening? Mn is a 3 by 3 matrix. Mn is a 3 by 3 matrix, whereas problem, they have asked everything for Nm, not Mn, which is a 2 by 2 matrix. Yes, anybody else? How will we approach this? Yes, Karan Malik.
Can we convert into AB
Yes.
equal to I format and then make them commute?
So yes, that is why. How will you convert this? That is what I'm asking you, na?
Big
In terms, yeah.
bringing 3mn this side and adding 3 by 9 by 4i on both sides.
You are making it, that equation you are doing as a perfect square, or making an equation in terms of mn. Rather doing that, can we generate an equation in terms of nm rather? Because I only require nm. So let me first write the equation. What is the equation? And mn into mn. This is mn square, and this is equal to how much? 3mn. This is your given equation.
Yes.
Yes, tell me. Now, since nm is required, so I am multiplying n to the left side, pre-multiplying n. So I should pre-multiply n here also. And I'm also post-multiplying m. So I must multiply post m in this manner. Is that clear? Can I do that? Yes, I can do that. Now, since associativity holds good, so nm, I'm going to club, and here nm and nm I'm going to club. So this I can write as nm whole cube. Is that clear? Because 3 by 3 matrix is there. 3 by 3 matrix. mn and then mn. So mn is going to be what is the order of mn? Tell me. M into n. That is 3 by 3. So like that, 3 by 3. Can I do that? Then 2 by 3 pre I can multiply, and similarly 3 by 2 post I can multiply. Can you check the commutativity? So this will become not commutativity, sorry, associativity. So what will this become? Nm whole square. Nm whole square. Is that clear? And since nm is invertible, so I can basically cancel nm square on both sides. See, when I say I cancel, I'm actually multiplying by its inverse. So don't take this like I'm canceling these terms. You're understanding, right? Or else you should understand in this manner. Nm whole cube is 3 times nm. So first you multiply by nm inverse. Then what will you get? This whole square is there. In steps you have to multiply. So if you multiply by nm inverse, you will get nm whole square. 1 nm will get cancelled, equal to this. Again multiply by nm inverse. So nm you will get as 3i. I believe this is understood by all. Tell me fast.
Yes, sir.
So NM is 3i. Now what is the determinant value of this?
9,
What
sir.
is yes. What is the order of I?
2.
So order of I is 2 by 2 only, no? Correct.
Yes.
So NM determinant will be 3 power 2, which is 9. Correct. So A part is correct. The rest will automatically follow. So P into NM will be how much? So P into NM is 3i. This is I. That means P equal to I by 3. If you substitute these values, so P plus, so this will be 1 P square, 1 by 9, 1 by like that. This is your matrix determinant value of this. So this is how much? 1 by 3, sorry. P is 1 by 3. A upon half, this will be half only. No? So what is the determinant of half I? This is 1 by. Yes, so your answer was correct, but this should be the way. This is clear to all? Yes? Tell me first.
Yes, sir.
Yes, sir.
Okay. Now next question. You write this. Let us see. Again, one or more than one correct options are there. Try this.
Plus
Okay. You have to be very careful. Look for all the options. I think what you have told is correct, but not complete. All possibilities.
So A, B, A, C, D.
Now you are correct. See, whenever then is there, whenever question says let this be valid, then means 100% true or possibility is also included.
100% true.
100%, because if something implies, that means whenever that is true, that should be true. Correct? So ACD is correct option. So how will you do this? Tell me. T is your transpose.
We'll take
Again?
transpose and add both the equations.
Again, simple equation. B square equal to A. And then if I take the transpose, TT taking transpose. So transpose has a property that exponent and transpose are invertible. Okay, not invertible, sorry, interconvertible. So this will be A transpose. As you said, I am adding these two equations. So obviously this is a null matrix. So first of all, D is 2. Now, why? Yes, tell me.
We can take B square to other side and add data on both, apply data on both.
Or instead we can subtract these two because directly C option is there. So if I subtract these two equations, what will I get? D square minus D transpose square equal to 2 times A minus A transpose. Correct? 2 times A minus A transpose. And what about A minus A transpose? What is this matrix? Let me just see whether I have given. Yeah, actually one thing should also be there, which you missed. In fact, I missed giving the question. These are of
Order,
third
sir.
order. Yes, so unless until I give you order, so these are third order. Okay, then only D will be correct. So strictly speaking, this question has only this answer D, because I cannot comment upon this. Skew symmetric matrix of odd order are singular, not of every order. Getting the point?
Can we, in third equation, we can send BT square to other side and take that, we'll get that B to be 0.
In the third equation, the second
Then
equation.
Third one, that B square plus BT square.
Yes.
We can send B square to the other side and take that. We'll get that to be 0.
How will you get without getting the order? Because you don't know the order, no? If
That
it is
one,
even order. Determinant, how will you get? I'm not getting your point. If you take the determinant, then -1 power what will come outside? Its order will come. So unless until I know the order, how can you say determinant B is 0?
Yes.
Getting the point? No? Yeah. So in fact, this should be kept in mind. I missed providing you the order. So if order is not mentioned, then this question will be meaningful only when D is true. Or in other words, if this holds true, then only D is guaranteed. Otherwise, if third order is given, then we can proceed in this manner. A minus AT is always a singular matrix or odd order because it is a skew symmetric matrix. It is a skew symmetric matrix. Hence, determinant value of this is going to be 0. 1 point. And obviously, A is true in this case also because it is a skew symmetric matrix. This is the property. What about B? Is B true? Is B true?
No.
Not necessarily. So unless until you provide me a counter example, we are not sure whether to include this option or exclude this option. So you have to provide me one counter example where this determinant could be 0 or this determinant could not be 0. Can you provide me a simple example? Like let me take A equal to I and B equal to null matrix. Does it obey all conditions?
Yes, sir.
Correct. And what is A square plus AT square? Is determinant 0?
2i. We need 2i, sir.
Yes, so obviously it is not 0. So B need not be true. Okay. This may be 0. And suppose someone asks you, sir, you also tell me whether when it is 0. Then I can again take the simple example, both to be null matrix. Both to be, then this could be 0 also, this could be non-zero also. Got it, na?
Yes, sir.
Okay. So let us write the next problem.
A, B, C, D.
All are true? Let us check. First let others do, then I will check. Okay. Simple problem. I think all are correct. Which of the following is not invertible? Tell me, how did you do?
I took A as I, sir, for just a case.
Then your approach is invalid. Because what you have shown that for a particular case, all could be true. But you have to generalize the case. For each such orthogonal matrix, the option which is always true will be taken as true. So please don't do this, that you have taken A equal to I. Then you might ask, sir, you were also doing the same thing. No, I was not doing the same thing. Because this has both the possibilities. Therefore, to rule out this, you can take an example. But to prove a general case, example won't work. Because someone might argue that you have proved these options only for I. What about other options? Getting the point? Getting the point?
Yes, sir.
Okay, so you should try this in a general way. Only for disproving a statement, you can take an example, not for proving or checking its validity. So tell me, how will you start? So let us first check the option A. Let us find its determinant. So its determinant will be A minus. What is I for orthogonal matrix? It is AAT. Yes. And if I can take A common, then this is I minus AT. And then can distribute the data. So I think you understood this step, right? All of you? Please tell me.
Yes, sir.
And transpose gets distributed over addition, difference, and inverse log for product. So determinant of transpose is transpose of determinant. So basically not transpose of determinant. Determinant of transpose is determinant of matrix.
Matrix.
Yes. So this I can write as I minus A. Determinant A is 1. So this is I minus A. So minus 1 into A minus. They have given the order. So this will be minus 1 cube into A minus I. Hence, what is the value? So like this you have to do. Okay. Again for odd order. This is only possible for odd order. If this had been an even order, then we are not sure. We can provide counter examples for both. So obviously A is true. Right? So similarly, how will you do the second part? Or the, how will you check the? Yeah.
A
You
plus
can
I
take
of
A
n
minus I
squared.
common. It is
Yes,
commutative, sir.
Very good. So this is quite easy since this is A minus I and one of them is a singular matrix. Therefore, its determinant also will be singular, will be 0. So this is also. What about this?
We can take
This
it
is
as B and multiply.
Skew symmetric. Skew symmetric, you should say, no? Yes?
Yes.
Skew symmetric.
Yes, sir.
No, not skew symmetric. Sorry, sir. It's not skew symmetric. If I take the transpose, this value will be same because it is symmetric only. So A minus AT. So how am I going to do this? So let me name this as B. Tell me.
Multiply A on both sides.
Yeah, the A square basically. No?
Yes.
No, if you're multiplying, okay, then you can invert that. No issues. So if I multiply A square, or rather I can take A common. Na? Yeah, that is one and same thing. AAT whole square. So this is A square minus I whole square. This is B. This is B. I can transfer A square to the other side.
Or we can take transpose now. I mean that now.
Yes, determinant now. In fact, I'm doing the same thing. I'm transferring A square to the other side. It is invertible matrix, orthogonal. Correct? And if you take the determinant now, then this will be 0 because A square minus I is a singular matrix. So C is also true. And obviously D and A, there is no difference. Determinant is already given. So all are true. Is that clear? Yes? Tell me fast. Then
Yes,
we'll do
sir.
the next problem. Okay. One or more may be correct. Try this. Okay, tell me. Is A correct?
No, sir.
So what is that you are getting in option A? A square is A. Right?
So AB plus B equal to 0.
Yes. B square is B and A plus B is also idempotent. That means A plus B whole square is how much? A plus B. So this you can write as A plus B into A plus B. So this will be A square plus AB plus BA. And then what? Plus B square. This is equal to A plus B. Correct. So what you are getting is for sure AB plus A square is A, B square is B. No? So AB plus BA is for sure 0. Acha, if AB plus BA is 0, can we ensure that AB and BA both will be 0? I don't think this is true, no? Are you getting it? AB plus BA is 0. So, not necessarily that AB and BA both should be 0. Can we provide a counter example that this will not always work? Are you getting the point, all of you? A need not be always true. Can we look for a counter example?
A and B are minus I each.
Minus I each won't work because AB plus BA you have to do as 0. And minus I square of order n, that too, because minus I if you put here, this will become I square plus I square, no?
I comma 0.
I comma 0 will do, no? If
It
A
is
is
proving
I,
it.
yeah, for disproving this only, correct. So, no, I comma 0 also this is working.
Then statement becomes correct, sir.
Pardon me?
Then statement becomes true.
We are looking for counter example that this is not true. We are looking for an example where AB plus BA is null, but AB and BA both are not null. Can we think of that example? Because anyway, we are not getting this result, na? Can we think of an example? That is what we are thinking. Because if you take 0, then obviously this will work. But I and 0 summer. It is not ruling out this. Na? If you put I and 0, it is working. I want a counter example. Getting the point?
Above equation we can multiply A on both sides. Sir.
Which equation?
Above which you wrote AB plus BA is equal to 0.
Okay, you want me A to multiply?
Yes, sir.
A square B plus ABA equal to 0. Okay. Then
A square is equal to A. Now AB common.
AB into I plus A is 0.
A cannot be minus I because it is idempotent. So AB has to be 0.
A plus I. AB into A plus I is 0. That is fine. But what about A plus I? A plus I is non-zero. So what? It could be singular, no? Are we sure that A plus I is non-singular?
If we put A is equal to minus I, then A square equal to A won't work.
You're not getting the point. I'm not saying that A could be equal to minus I. All I'm saying is even I plus A determinant could be 0, no? This could be equal to 0. Even if A is not equal to minus I. I'm not taking A as minus I. So if this determinant is 0, then I cannot say that AB is null matrix. See, if AB into A plus I is a null matrix, then you should not say that if this is non-null matrix, then AB will be a null matrix. This is not true. If this determinant is non-zero, then AB is null. Because if this determinant is non-zero, you can post multiply by its inverse to get ABs as a null matrix. Are you getting this point?
Yes, sir.
You're getting the point. So what you are only telling me that A is not equal to minus I, that is fine. But I want to make sure A plus I is non-singular. That is not the case. I cannot make A plus I non-singular. Okay, so this need not be true. Okay, exact example we cannot think of because simply B equal to 0 and A is not working. Probably if we can write something that yes, someone has given me some Raman, A and B he has given me. So that is working, right? But AB is not coming out as 1001, 1010. So he has taken A as, yes, we have to work out some example. So Raman, can you tell me 1010? Is that you are sharing? No. Determinant of AB is 0, that's fine. But what about AB? What about AB? And B you have taken as 1100. So B he has taken as 1100. So what is AB here? What is AB? Correct, it is non-zero. And AB plus BA, do they anti-commute? AB plus BA, is it coming out as 0? AB plus BA. No, but then this example won't work. You are not getting the point. You have to look for an example where AB plus BA is 0, but AB and BA are both not simultaneously 0. Okay, you can work out and tell me later. But one is not always true. Okay, so let us check other options. Actually, providing counter example will be like 100% satisfaction for us. That is why we are exploring. But anyway, it is not necessary that we are not able to prove. There is no way that we can prove AB and BA both to be null matrix. Okay. So now second option, if A and B are orthogonal, then AB and B are orthogonal. I believe
Always
this is
true.
correct. This is always true. This you must know, because for AB to be orthogonal, I can take AB into AB whole transpose. Then this you must know, B transpose A transpose. This is I. So A transpose, this will be I. So this is a universal property of orthogonal matrix. Correct. Next, C part. I
C
think
is nothing but A.
Tell me.
C is nothing but A parts.
C is nothing but A part. Why?
I mean, if we square, we'll get B square equal to, I mean, if I send B that A that side and square, I get B square equals to B.
But that is not the case. Here he has taken A plus B to be a special matrix. No? So if C is true, then A is true. This is not correct. But if A is true, then C's will always be true. So C is not the generalization. A is the generalization. Getting the point?
Yes, sir.
They are not identical parts. This is just a particular case of A, C part. So you should not say that they are same. So let us explore this. I think this time AB and BA both should come out as 0. Let us try. So tell me, if A is idempotent, I can write A square equal to A. And A plus B is I. So what you are going to do now? I think we must try multiplying by A, pre-multiply. So let me pre-multiply. So this is AB equal to A. Correct? So A square and A are equal. So obviously AB is coming out as a null matrix. Now I can do post multiply by B. And acha, AB is null. What about BA? How will I get BA? Post multiply by A, sorry. Not B. Post multiply by A. So this will be A square plus BA equal to A. Again, A square and A are equal. So BA is null matrix. You are getting this or not? So see here, for A plus B equal to I, even if in A part he has given A plus B to be non-singular, then this will do. Because then A plus B will automatically become I. Because if A plus B whole square equal to A plus B and A plus B is non-singular, then you can say that A plus B must be I. But since he has not mentioned that case, it's not always true. Is that clear? So C is also true?
Yes.
Getting the point? And what about D option? This is a beautiful option. Option D.
True.
True. Very good. You're able to obtain this?
Yes.
Yes. Tell me, how will you start? Using that, you have to show that.
Sir,
So, tell me.
BA can be written as BA whole transpose inverse.
BA can be written
As BA is orthogonal matrix, we can write BA as BA whole transpose inverse.
where B is orthogonal matrix, it is given. Where it is given, beta? This is not given. In fact, this is a very good option. See, you should try this, all of you. Let me explain this. Trace of, see, what are the properties of trace? Tell me. Trace of AB is also trace of BA if A and B are square matrices. All of you know this? Interchanging does not change the diagonal sum of diagonal entries. Tell me.
Yes.
You know this
Yes.
property or not? And trace of A plus B. So basically we are going to apply this property. These two properties. Trace of A plus trace of B. Okay. Now check the LHS. So how can you express the LHS? Trace of AB into AB. This AB, first AB I want to write as A square plus B square into AB. Correct? This I can write as trace of A cube B plus what? Plus what?
ABQ.
No, you cannot do commutativity here. You cannot transfer.
B square AB, sir.
B square AB you should write. Correct? And then what about trace of A square B square? RHS. So what is going to be your RHS? So this you can write as, tell me, A square B square. So A into AB into B. So this will be how much? Trace of A. What is AB? A square plus B square into B. Yes. So this will be how much?
A cube B plus AB cube.
Trace of A cube B plus trace of AB cube. I can write that also like this. And here you should apply like this. Trace of A cube B in the above and trace of B square AB. Now see, for product, commutativity holds true. So B square into AB I can interconvert and write AB into B square using the above property. Please tell me this.
Yes.
Because now this is also AB cube. So like this you should argue. So obviously D is also true. Is that clear to all?
Yes.
So B, C and D are correct. So I will take your leave and
In the
then
first
we will
option.
continue. Yeah, only
In the first option, after writing AB into I plus A, if I
Yes.
substitute AB as minus BA,
just a moment. How did you do? Please tell me. What are you doing? I shall write it.
earlier we got A,
Earlier you have got AB plus BA as 0 for the first part. Hai na?
yes sir.
Then
we
what are you doing?
multiplying A on both sides, we got AB into I plus A.
AB into I plus A you have got.
We know AB plus BA is 0, so replacing AB with minus BA.
Just wait. AB plus BA is null matrix. We multiplied this with A. So A square B plus AB. Yes. Now AB plus BA is 0. So you want to replace AB with minus BA?
Yes sir.
No issues. So BA into I plus A will also be null matrix.
Now opening the bracket,
Okay. So AB plus ABA is null and BA plus BA square is null.
A square can be written as A, so BA will be equal to 0.
Yes, yes. BA into I plus A. Yeah, this seems promising. BA into I plus A. And now BA plus this A square you can write as A. Correct.
Yes.
So this BA is also true. Very good. That means this is also coming out as true. No? So B is null matrix. And similarly, AB is also null matrix. Yes, both. So that means A is also true. Please check, everyone. AB into I plus A is also null. So AB plus ABA and then BA into I plus A is also null. So BA into I plus A. That means BA plus BA square. BA square we can again write as BA. So BA is null and once BA is null, AB is also null. That is why it was coming out null in every case. Good. So all options are correct. A, B, C. Is that clear to all? Yes?
Yes, sir.
Okay. So I'll take your leave. We will continue in the next class. Okay? Okay. Take care.